Who runs?
Today, I was going to talk about Avalanche. Hey, it's Neil with Bull Runs. So with Avalanche, in May of 2018, 3 people conceptualized the Avalanche. And they were Kevin Seknicki, Mayofan or Ted Yin, and Emin Gün Sirer. A group called Team Rocket first released fundamental information about their protocol. It launched in 2020 by Avax.
It is from my vantage point, so it's things that I know about. There's much, much more. But I do want to share with you some of the exciting things that I, as a techie, find compelling. We bring hard science to this nascent area where it's badly called for. There are many large, open, outstanding scientific challenges ahead of us, and we are one of the few teams that have the expertise to bring in scientific solutions to long-standing, open, hard problems. We did this with consensus protocols, with bridges, with DEXs, with swaps, etc., and we're doing it as a community across the board, all throughout the software stack. One of the main things that's happening at the platform level is that we're continually working on scaling and making cheaper and faster the basic platform. The demand for blockchain space is intense.
Avalanche is the blockchain platform that is a smart contract capable. Avalanche, or Avax, AVAX, is a cryptocurrency and blockchain platform, Avax being the native token. Like Ethereum, it uses smart contracts to support a variety of blockchain protocols projects. Avalanche blockchain can handle near instant transaction finality. Avax is used to pay transaction fees, secure the network, and act as a basic unit of account. The smart contracts platform supports both decentralized and applications to anonymous blockchains. The max supply of Avax is capped at 720 million. Users govern how fast new coins are minted. Holders can control the creation by voting to adjust the amount of Avax paid as a reward for adding a new block.
There's 700 trillion worth of assets, I keep saying this, and there's going to be more as we create the ability for people to create more virtual assets. All of that value, as it goes on to chains, it's going to crowd out other uses. And that you need to have the right kind of infrastructure to absorb this. But there's also the need for continually improving the basic protocols for executing transactions on a chain. We've been doing this with Snowman++. And in the same vein, there is another release coming out called Avalanche V2. It's going to bring with it fast synchronization. So as chains grow, we have the problem that syncing up a node or bringing a node up for the first time can take some time. We want that to be incredibly fast. So we're going to be introducing fast sync and secure checkpointing to the chain. And with that, it's going to be very, very fast to bring up a node to catch up to the latest state of the network. Is that we have this amazing DAG that we can build on the X chain with the Avalanche virtual machine. A DAG is a directed acyclic graph. It allows many concurrent activities to take place in the network. And so we discovered that it's actually not easy to integrate with exchanges.
Transaction fees vary depending on the type of transactions and network congestion. All fees are burned out of circulation to enable scarcity over time. Avalanche users vote on transaction fees, making fees possible to change. The consensus mechanism, the transactions on blockchains are confirmed using a method that requires a small amount of network participants to confirm transactions before the transactions are considered finalized. Avalanche sought out a solution to common problems of older blockchains like Bitcoin. These have a lack of interoperability and problems with scalability and usability.
If you have a DAG. So we're going to be, for those people who want to create subnets based on value creation, etc., we're going to be giving them the option to create a linear chain using the Avalanche virtual machine. So for those of you who want to create assets, do asset transfers, etc., in your subnet, and you want to integrate with exchanges easily, this is going to be one of the primary mechanisms. We're working on a new EVM, and one of the main things it's doing is it's doing state management differently than what you see in Geth. And it also has some mechanisms that we're currently adding into it for control of state growth. So this is something that a lot of people bring up, which is, oh, you're super fast now, but in the future, there is going to be the specter of state growth that's going to get you. And I've often said to this in response on Twitter, trust us, there is a solution. Well, now we're sharing with you for the first time that indeed we've been working on a solution for controlling state growth. We've been working on, or we've been thinking about a low MEV subnet. You've heard of MEV. This is essentially, those of you who've ever traded on Uniswap, on Ethereum, know that you are constantly sniped, that somebody comes between you and the thing you want to buy. And we've been thinking about mechanisms, some based on commit-reveal schemes, that lower the MEV extractable by other parties on-chain. This is forever going to be a cat-and-mouse game. But we can get way ahead of the mice in this game by introducing some technologies, basically some basic crypto and some trade-offs of latency for security, of latency for user experience. So one of the things we're thinking about is a subnet that essentially does not have the same super fast latency as the main C chain. It might be maybe a few times, like instead of a sub-second latency, it achieves 5-second latency.
The three blockchains that make up the Avalanche mainnet are X-Chain, which this blockchain is used for managing assets. It uses the Avalanche consensus protocol. Then there's the C-Chain. This blockchain uses to create smart contracts, and it uses the Snowman consensus protocol. And then there's P-Chain, which is the third. This blockchain is used to coordinate and coordinate validators. It also uses the Snowman consensus protocol. With that, it's Neil. Bull runs.
Bull runs.